And now, please welcome to the stage DARPA applied physicist Vincent Tang.
Today, 9 nations have the capability to make a nuclear weapon. And the components for a weapon, or a much simpler radiological dirty bomb, can be found anywhere around the world. Even one terrorist detonation would be catastrophic and could escalate the risk of nuclear war to levels we haven't seen since the Cuban Missile Crisis. So if a weapon or the materials needed to make one goes missing, how do we make sure we find it in time if we don't know where to start? Well, the weapon or the materials in them are radioactive. And what this means is that they emit neutrons and photons 1 million times more energetic than visible light. Not too many things shine this way, and so we can concentrate on building detectors that focuses on those characteristic energies. So think of it as the weapon or the material's unique color. Problem is, these detectors are limited in range, and especially in cities, there are actually a lot of radioactive things. Hospitals, factories, even the buildings themselves, depending on what we make them out of. A single nuclear medicine patient can set off false alarms from blocks away. So we're potentially looking for small signals in a cluttered and shifting background. Think of it as looking for a burning candle in the middle of Times Square, looking through a straw without your glasses on. Now, you wouldn't think it'd be so hard, but how do you know you're really looking at a burning candle and not just an orange taxi cab or just a really bright neon sign? Well, today, we rely on experts to tell us ultimately what we're seeing from these detectors, and we expand our capabilities and coverage by training first responders like police officers to carry detectors. Problem is, the detectors we give them are not as smart as we like, they're expensive, and they can generate false alarms. And when they do, we call on that expert to tell us, are we really seeing that burning candle? Now, it all works, but it's not easy. What if we could build an automated detection system that was always on, learning, moving, and adapting in real time? What if we could make it so easy to use and so easy to scale and to sustain? These are the goals of DARPA's Sigma program. And to do that, we're doing 3 things. The first is new detectors. This detector is $400. It replaces a device that's normally $10,000 and the size of a shoebox. Almost no user training is required to be effective with this. The second is moving from individual sensors to large networks of sensors. When the detectors are networked, they can use machine intelligence to discriminate real threats by learning the spatial temporal background of normal medical, industry, and other background sources. This is one way we're going to bring down a number of false alarms. The third is tapping into the rhythms of daily life. We're exploring concepts that move beyond first responders to people and vehicles that move around all day, every day. So how may all this work? Let me show you. So what you'll see here in a second, these blue markers represent people or vehicles that are carrying detectors. With that information continuously coming in, we can build heat maps that look like this. The system is continuously assessing this data against threats. Here we're looking at 3 detectors coming together in a space, and the system aggregating that detector data intelligently, and then comparing it against a threat template. If it finds a threat, it can then elevate an alert for action at a higher level. So success for us is at a minimum a continuous, always-on, and affordable wide area monitoring capability equivalent or better to our most concentrated, highest alert, all available asset operations. Let me now leave you with this. I think some things that can sometimes get lost in all the talks of national security and capabilities are real customers. At DARPA, we're making not even once a reality, and we're well on our way. Thank you.